So let me show you something cool that I just learned. Okay. So let's say that you are testing a website and you're navigating through the different functions of the website, enumerating information, right? You're trying to see what pages exist, what can you click into, what information can you gather, and you're clicking around and you find a login page. So this is really juicy for us, right? No pun intended, because now we have a login page, and this is the gate that the only thing that's stopping us between having access and not having access to the application. So imagine if we were able to bypass this, if there was some sort of vulnerability or exploit, something that we can take advantage of to be able to log in. Now, the first thing that comes to mind when we see a login page is like, oh, well, we can brute force this, right? We can try a series of emails and a series of passwords and hope that one of them is the correct one and log in. And sure, we can definitely do that. And that becomes even more possible if we do really good recon and we're able to identify legitimate emails, and maybe find some passwords that have been leaked through past hacks, right? So that is a possibility. However, let's not go that route for now. Let's hang that in the closet. And let's remember that this is a web application. And the web applications have their own set of vulnerabilities and their own ways of working. And that's where we introduce and that's where we learn about the OWASP Top 10. OWASP is a foundation that focuses on cybersecurity for web applications. So if we look at 2021 and we look at the top 10 most common vulnerabilities for web applications, we'll notice that number 3 is SQL injection. So what is a SQL injection? Well, a SQL injection is an attack that consists of insertion or injection of a SQL query. So we're basically inserting a SQL query. Where though? Well, we're inserting it via the input data from the client to the application. Oh, so you mean something like this? Yes, exactly. So if we can insert a malicious SQL query in here in the client and send it to the application, if the application doesn't know how to deal with it, we might be able to perform certain malicious things. Well, what can we do with it? Well, a successful SQL injection exploit can read sensitive data from the database. It can also modify the database data, so we can potentially perform some insert, update, delete. It can execute administration operations on the database. It can recover the content of a given file present on the DBMS file system. And sometimes it can also issue commands to the operating system. Okay, so that is pretty cool. But one of the things that's not listed here is that, and the question that we have is, can we use SQL injection to bypass this security, to bypass the authentication check? Well, the short answer to that is yes, we can. If it's vulnerable to SQL injection, then yes, we can. But there's two things that we need to keep in mind. First, is it using a SQL database, right? Is it using a SQL database in the back, and or some sort of SQL? It doesn't have to be Microsoft SQL, just some sort of database that utilizes SQL language with, which now that I'm thinking about it, yes, most of them do, right? If I go down the list of like Microsoft SQL, MySQL, NoSQL, if we think about SQLite, if we think about Oracle, right? All of those use some sort of SQL language if they're not exactly the same. So more than likely it is, but okay, let's say that we want to confirm that. So we can do some quick checks. For example, if we utilize Wapalizer to see what technologies are being used. This is not really helpful because it's just going to give us the technologies being used and presented in the website itself, and the database is usually internal. So no, this doesn't really tell us whether or not it exists. The other thing we can do is that we can do a quick query for port 1433 to see if MySQL, right, or SQL database is open. Well, this port is closed. But again, this is only for MS SQL. So, I mean, we could do an nmap, and we can do all ports, and then we can do a 10, 10, 219, 144, and see what this brings back. See if we're basically probing every single port, TCP port open on this machine to see, okay, is any database port open? Because then that'll confirm whether or not it exists. What else can we do? Well, we can also use Burp Suite, right? So we can do this. If we set a proxy, right, we turn that on, and we go here and we put intercept on. Now the proxy is open. Let's say we do a quick test, and then we do a quick test, and then we log in. Okay, so the intercept is going to catch it. Just beware that the first one or the first few may not be the one you're looking for. Notice that this is a GET request. We're looking for a POST request. Okay, here's a POST, and here it is. This is the email and the password that we actually inserted. Okay, perfect. So let's send this. If we right-click here, we'll send it to repeater, and then we're going to send this here to see what response the website gives us. So the website is going to give us a 401, which means 400 means it's not an error. It just means like not found or forbidden, etc. It's kind of like a deny code. And indeed, it is a deny one. This is telling us this is unauthorized. And what's the message? Well, invalid email or password. Okay. So just telling us, hey, we didn't find this. But notice that this doesn't really give us much information yet. Let's go back to our scan. It's still performing the scan. That's no problem. We can still play around here. So the cool thing about the repeater is that I have this request that I can send over and over. I can make a change and send it again and again and again. So what if we tried to make an error by putting a weird character like a single quote at the end of the email, right? Will SQL like that? Does it know how to handle it? Well, let's see. No, it doesn't. Notice that now what we get is a 500, and that is an internal server error. And that's what we're looking for. We're trying to get errors and see if perhaps it gives us some information. So notice here that there's a SQLite error. Okay. Here's the name, here's the code, and here's the SQL. Okay, so this is actually giving us what the SQL statement is what the SQL statement is. And it's telling us that the SQL statement is a select all from the table users, where the email is going to equal this, and the password is going to equal this. So obviously it's performing a hash of the password, and it's not sending it clear text, right? And deleted at is null. So perfect. So this is the statement. So now we can play with this and see if we can bypass it. Notice that there doesn't seem to be any checks besides, hey, just compare email and compare password, and just delete everything if it's null. If they enter nothing, just delete it, right? So that is pretty cool. So the question is, what can we do here? What can we do here? So if we look at how to test for SQL injection, because that's what we want to find out, can we actually perform a SQL injection in these fields right here for this website? Well, here it says that in general, the way that web applications construct SQL statements involving the SQL syntax written by the programmers is mixed with user supplied data. Example, select title, text from news, where the ID equals the input parameter, which is the $ID, okay? So in the example above, the variable $ID is going to contain the user supplied data, meaning that that's what we're going to enter. So every SQL statement used by websites is a combination of what? A predetermined query and a variable that the user inserts. So they're hybrid statements. Okay, let's continue reading. Well, the remainder is the SQL static part supplied by the programmer, making the SQL statement dynamic. Why dynamic? Because it can change. What can change? The user input or the user variable that's provided. Because the way it was constructed, the user can supply a crafted input, trying to make the original SQL statement execute further actions of the user's choice. The example below shows where the user supplied data 10 or 1 equals 1, changing the logic of the SQL statement, modifying the where clause by adding a condition or 1 equals 1. So it's saying that instead of just putting a normal variable like 10, we can do 10 or 1 equals 1, which obviously this is a Boolean statement, meaning that this is a true statement. The input parameter, normally we would enter a normal variable. Here would say from news where the ID equals 10. But now we're changing it to say where the ID equals 10 or 1 equals 1, meaning equals true, which might make the entire statement true. So notice that now this is what the statement looks like. Select title, text from news where ID equals 10 or 1 equals 1. Okay, perfect. So that gives us an idea, right? So here, basically, we can add something in the email to change the rest of the SQL statement. So what if we were able to comment out this or just make this statement true? Well, let's check it out, right? So what if we do, just like we saw there, test or 1 equals 1. We're going to change this statement based on what we saw here. So let's take a look. What if we just do this and we send it? Let's just make sure the proxy is on. Let's make sure that Foxy proxy is on. There we go. Okay, so now we're going to go to repeater and we're going to send this. And it's going to tell us that 401 is unauthorized. And that might be because, well, we did something with the email which equals true, but then the password is still incorrect. So what if we were able to just comment out the password, right? If we remember the statement, it was an AND statement, password equals blah, blah, blah. Are we able to see the history here? Yes, we are. So remember that here, where email equals test. So now if we convert this into true by adding a or 1 equals 1, but then it has an and this. What if we were able to comment this out? That's interesting. Okay, so let's say that we want a or 1 equals 1, finish the statement, and then we're going to add at the beginning of the next statement these 2 dashes. And what is that going to do? It's going to comment out the rest of the SQL query. Notice that we have gotten so far a 401 unauthorized and a 500 internal error and a 500 or internal server error. Okay, so let's try this. And it deleted it, what we just did. So let's put that in and let's see what we get. Okay, and we still get an unauthorized, and that is interesting. So I think that what we need to do actually what we need to do is to enter this. There we go. Okay, so we're going to enter the test. Okay, so let's do this again. Let's do this again, because let's do this. Yeah, we get the server error. Okay. So when we put this little quote, it opens up basically a second statement. So you have the select from where this equals this, and then it opens this up. What if we were to do, okay, so let's do the or 1 equals 1. Okay, so we have, it closes the test, or 1 equals 1, and the password, okay? So let's close this out and then add the 2 dashes to comment the rest out and see if that works. And that worked. And we are in. First thing to see, HTTP 200 okay, meaning that, yep, the website is good. The response is an okay, that it accepted what we posted. And notice that here it says authentication token, and this is our authentication token. This is our token to log in with, and we're logged in as admin juiceshop.op. And just like that, just by commenting out the and password equals this, we were able to log in. So let's turn this off. And let's see if we're in. Okay, so let's do it in here. Let's do the test. Or 1 equals 1. And we're in. And just like that, you're in as the administrator or as one of the users. So just like that, using a SQL injection flaw in this application, we were able to bypass the authentication restriction, the authentication control for this website. Pretty cool, huh? Learning new things every day. I hope you enjoyed this, guys. I'll see you in the next video. Bye.